let's take a look at two problems for the 10.8 Day 1 homework help. I'm going to sketch two graphs, polar graphs now. We'll sketch the graph of r is equal to 4 times the quantity 1 minus the sine of theta. And then we'll also take a look at sketching the graph of r is equal to 4 plus 3 times the cosine of theta. Alright, so first thing we have to do is we need to generate a table of values so that I can graph them. So let's do that. And it doesn't matter where you put r or where you put theta, that's kind of up to you. So I'm going to put theta here and r here, because theta is kind of like x. I'm going to be plugging numbers in there. And then if you remember what we did in class, we said that you should have 7 numbers to plug in for theta. 1, 2, 3, 4, 5, 6, 7. And we also said that you need to pay attention to whether you're using a sine function or a cosine function, because it's going to tell you how to do your reflections, and it's going to tell you what values for theta. This is sine, so think of arc sine. Arc sine is restricted from negative pi over 2 to pi over 2. And those are the numbers that we are going to use for theta. Negative pi over 2 to pi over 2. Now when I do this, I tend to skip the 45s out. I guess I really don't have a good explanation as to why, other than the numbers are a little bit more messy, but you could easily put them in there, which means you'd have 9 of these things. So I'm going to start with negative pi over 2. So think on your unit circle, negative pi over 2. If I move over, the next one over is negative pi over 3. And then like I said, I skip the pi over 4, so the next one for me would be negative pi over 6. Only reason I do that, like I said, is because the square root of 2 over 2, you end up dealing with a lot of decimals, and I guess it doesn't affect your graph that much to skip that 1 point. Yeah, you're going to end up with decimals with one of these two too, but like I said, it's just something I do. I'm weird. Alright, so negative pi over 6, then the next one would be 0, then pi over 6, then realistically pi over 4, but I skipped that, pi over 3, and then pi over 2. So those are the 7 numbers that I'm going to plug into this and then try to evaluate it. So obviously you need to know your unit circle. Most likely on a test you're not going to have a calculator. If you need a calculator to help yourself out here, you can do that. Alright, so let's run through and do it. So I've got 4 times the quantity 1 minus sine of theta. So now I'm thinking on my unit circle. Alright, down here at negative pi over 2, what is the sine of it, or what's the y value at negative pi over 2? Well, I know this point is 0, negative 1, so I know the y value is negative 1. So it's 1 minus a negative 1 or 2 times 4, so this should give me 8. Now, I move over to something over 3, so it's a 60-degree reference angle. I know at a 60-degree reference angle, the point is 1/2 square root of 3 over 2. Of course, this is going to end up being negative. And now if you have something like this on the test, I will tell you what negative square root of 3 over 2 is as an approximation. It is basically, here, square root of 3 over 2 is basically 0. This is not exact. It's 8.6. It's actually 8.666 repeating. I'm just going to give you a decimal so that you can kind of ballpark it. Like I said, it doesn't have to be exact. It just has to be ballparked. Alright, so the sine of 60 degrees is going to be negative 0.86. So it's 1 minus a negative, or plus obviously, is going to be 1.86 times 4. So I'm doing exactly what I would want you to do if you were doing this. Multiply it by 4. That's 24. 32, 34, carry the 3. Looks like it's 7.44, and it doesn't need to be all that accurate. All I need to do when I graph this is basically between 7 and 8. Alright, I move over to negative pi over 6. That's a 30-degree reference angle. So here's the point, square root of 3 over 2, 1/2. So I'm looking for 1/2. And of course it's negative because it went down. So it's 1 plus 1/2, or 1.5, times 4. If you need to multiply that out, you've got 4 times 2, it's going to end up giving you 6. Alright, 0 degrees are radians. At 0 degrees, I know the point is 1, 0, so the sine is 0. So it's 1 minus 0 times 4, or 4. And then these things, same thing, just different signs. At 30 degrees, the sine is going to be 1/2. 1 minus 1/2 is 1/2, times 4 is going to give you 2. Said you're more than welcome to plug it in the calculator if you need to. Try to do it out by hand. That would be given to you on the test so that you don't have to try to guesstimate what you think that is. Pi over 3, that's 60 degrees, so that's going to give me that goofy number. It's 1 minus this, which would be 0.14. Multiply that by 4, or take 14 times 4 and put the decimal point back in. Multiply it, it's going to give you 16. Looks like it's 0.5-ish. So if you just said it was 0.5, that's fine. I just need to know that's between 0 and 1. And then pi over 2 right here is 1. 1 minus 1 is 0. Multiplied by 4, still going to be 0. So those are the numbers I need. So when I go to draw myself this polar graph, I need to go at least 8 tick marks out. So draw yourself 8 circles, and this is probably going to get really messy, but that's okay. 3, 4, 5, 6, 7, and 8. Alright, so I've got my polar graph. And now I'm going to go ahead and plot my points. And I'm going to understand that when I plot these points, I'm not going to have the entire graph. I'm going to be using symmetry. Because it's sine is like a y value. That means it's symmetric over the y-axis. So let's plot all these points to start with. Now remember, this is a point, so it's 8. Go to the right 8. Rotate negative pi over 2, which means I'm going that direction. So that's going to put me right here. Alright, now it's 7.5, let's say. So right here. Rotate negative pi over 3, or 60 degrees. That's going to be approximately here. I don't have those other little line segments in like you probably do, so I'm just going to have to approximate the best I can. Alright, so 6 would put me here on this ring. Rotate negative 30 degrees. That's about here, I would say. R this time is 4. 1, 2, 3, 4. Rotating it 0, so don't move at all. It's right there. Next is 2. Go to the second ring. And rotate it pi over 6, or 30 degrees, so about there. Next is 0.5. Rotate 60 degrees, so it's about here. And then 0, doesn't matter how you rotate, it's going to end up here. And then a lot of times I will number them so I know the order. I'm basically going to draw and kind of connect the dots, if you will, in kind of a curved motion, if you can. Looks something like that. And now because this is a sine graph, that means it's symmetric over the y-axis. I'm basically just going to try to mirror image this thing, or reflect this over. So if it looked like this, it's probably going to do something like that. And your graph, obviously that's not the best picture you've ever seen, but that's basically what your graph is going to look like, almost like a heart shape. Alright, so there's the graph of this particular function. Now if I'm looking at this on a test, here's exactly what I'm looking for. Looking at these numbers again, those numbers, they just need to be ballpark close. These numbers should be exact. I'm looking at these specific points. So even if you have this picture drawn, but you don't have those points labeled, you've got, for whatever reason, these points labeled, that means you rotated the wrong way or you did something wrong. So I'm going to be looking at those points specifically, and then I'm just going to look at your picture. If it looks anywhere close to this, you got credit for it. Alright, so now looking at this one, same idea, this time it's cosine. The restrictions for cosine are from 0, including 0, to pi. So when I make my little table, I'm going to go from 0 to pi. And because it's cosine, it's like an x value, it's going to reflect over the x-axis. So let's go ahead and give ourselves a table again. And I'm going to put theta on top, r on the bottom. You can do that however you want. Give yourself 7 spaces. 4, 5, 6, and 7. Alright, and because it's cosine, we're going to go from 0 to pi. Again, I skipped the 45s, but start at 0. The next one I would see is 30 degrees, or pi over 6. The next one, if I skip the pi over 4, would be pi over 3. Then pi over 2. Then next would be 2 pi over 3. And then skipping the pi over 4 would be 5 pi over 6, and then eventually pi. Alright, and let's run through and calculate these out. So, cosine, so I want the x values now. So if you again want to draw yourself a little unit circle, go for it. here is 0 degrees. I know the point is 1, 0, so the cosine of 0 degrees or radians is 1. It's 4 plus 3 times 1, or it should give me 7. Pi over 6 is here at 30 degrees. This is the square root of 3 over 2, 1/2. And again, you would be given that the square root of 3 over 2 is approximately 0.86. So you're going to have to multiply that by 3 and then add 4 to it. So 0.86, multiply it by 3. If you do lattice multiplication, that's fine. I know how to do that. I'll follow that through as well. So I get 18, it's 24 with the 1s, 25. It looks like it's 2.58. I'm going to add 4 to that. So I get 6.58, or really, I'm just going to pretend like it's 6.5, somewhere between 6 and 7. All right, pi over 3, or 60 degrees, I know that's 1/2, square root of 3 over 2. So it's 3 times 1/2, so 1.5, plus 4 should give me 5.5. Pi over 2, I know this is 0, 1, so the cosine of pi over 2 is 0. 3 times 0 is 0, plus 4 should give me 4. 2 pi over 3, same thing as pi over 3, only negative. It's negative 1/2. So it's going to give me negative 1.5 plus 4, or 2.5. 5 pi over 6, that's going to give you negative square root of 3 over 2, so negative 0.86. Multiply it by 3, which should give me the same number, only negative. So it's negative 2.58. Add 4 to that. That should give me positive 1.42. And again, all I really care about is between 1 and 2. If that number's slightly off, I'll be generous with you there, as long as it's somewhat close. And then over here at pi, this is negative 1, 0. So it's going to be 3 times negative 1, or negative 3, plus 4, or that gives me 1. And so drawing out another set of polar axes, it looks like I need to at least go out 7 this time. So 1, 2, 3, 4, 5. Hopefully you've got your polar graphs that I gave you, or realistically I don't necessarily need these circles on here. I could easily just put tick marks and then kind of guesstimate. It's kind of nice, kind of cool to have the little circles, at least I think so. Alright, so first one is 7, and then rotate 0 radians. So 7, don't rotate, or rotate 0 radians, there it is. Next one, 6.5, I'm going to say, and then I rotate 30 degrees, so right about there. Next point would be 5.5, so 1, 2, 3, 4, 5.5, and rotate 60 degrees, so that's going to put me right about here. Next is 4, 1, 2, 3, 4, rotate pi over 2, or 90 degrees, so that's going to be here. The next one I have is, where are we at? 2.5, so 1, 2.5, rotate 2 pi over 3, that's 120 degrees, that's right there. Next is 1.5, let's say that is, and rotate 5 pi over 6, or 150 degrees. That should take me to right around there. And then 1, rotate 180 degrees, should look something like this. And if I do this all the way through, I'm going to have a curve that looks something like this. And then again, we're going to do that mirror image, because this is cosine. That means it reflects over the x-axis. So you kind of mirror image this thing best you can, and it should look something like that. The ones we did in class looked more like this, where you had that little inner loop. They don't always have to have that inner loop, like I said. As long as you've got these points correct and then you mirror image it over the right axis, you'll be fine. Get a little bit more practice with this tomorrow, and then we'll learn a bunch of rules tomorrow that'll help me graph that without having to sit and plot points. Alright, that's your homework help for 10.8. Feel free to come in for help if you need it.